So welcome everyone to today's webinar for the Community Care Smart Assistive Technology Collaborative. We've got a great lineup of speakers today on 3D printing in assistive technology. Just firstly, a little bit of housekeeping. Before we start, I'm Anne Livingston. I'm going to be the moderator of today's session, and I'm the chair of the Community Care Smart Assistive Technology Collaborative. We've been in operation now for some 7 years, and we've got a large community, over 2,000 individuals who are collaborating on projects and activities regarding smart and assistive technology and community care service delivery. You're placed on mute for today's webinar, and that shouldn't, though, stop you from asking some questions. And questions and comments can be posted in the Q&A panel. This has been a really subscribed area of interest for our registrants, and we know that we've already received a number of questions for the speakers today. But get your questions in early. That'll allow us to get to as many people as we can. So a little bit about us. Global Community Resourcing has been auspicing the Community Care Smart Assistive Technology Collaborative with the initial support of the Queensland Government. We've now got a national and international reach, and we've been fortunate to collaborate with a range of national and international projects. If you haven't already registered, you can see the details on the site now. Just by way of opening today's session, we just confirm that Global Community Resourcing is not promoting or endorsing any particular product research entity or organisation. Rather, our purpose of our webinars is really to bring up-to-date information to the wider community of interest and of practice around smart and enabling and assistive technologies in community care, and demonstrate what is in development, in deployment, what's being researched, and what might make a difference. So it's my pleasure today to introduce our two guest speakers, Sarah Hayman and Leona Holloway. They'll present on an ARC linkage project that they've been working on with Monash University, and will share some of their success stories on 3D printing for accessibility. They'll also provide some tips on how to get started with 3D printing to address your organisation needs, and this practical advice is really going to be well received. The ARC Linkage project investigates the use of 3D printing for accessibility through touch with Statewide Vision Resource Centre as a partner. The 3D printing provides another option for students who are blind or who have low vision to access graphics, and it can be used to create custom tools for the classroom, and also has great applicability to a range of community service provision. By way of introduction, Sarah was a secondary maths and science teacher before starting her current job as the Blind and Low Vision Technology Library Coordinator at the Statewide Vision Resource Centre. That's based in Melbourne, Victoria, and she supports the transcription team by designing or finding 3D prints with that link with the curriculum. Welcome, Sarah. Our next speaker is Leona, and Leona is a researcher with Inclusive Technologies Group in the Faculty of Information Technology at Monash University. She draws on her background as a braille and tactile graphics producer, and she investigates the use of emerging technologies to enable better access to graphics for people who are blind or who have low vision. Welcome, Sarah and Leona, to the Community Care Smart Assistive Technology Collaborative. We look forward to your presentation today.
So thank you very much, and it's great to be with you all today to talk about our project and also how it might be able to apply for you. So we've already talked about who we are, so we'll be quick on this section. So my name's Leona, and I'm from the Inclusive Technologies Group at Monash University. We're from the Department of Human-Centered Computing, so we're very much interested in looking at the user perspective and being directed by the community in terms of what's needed for the use of new and emerging technologies.
Sarah, I work at the Statewide Vision Resource Centre, or SVRC, which is part of the Department of Education and Training here in Victoria. And we provide 5 core services to support students who are blind or have low vision, or BLV, across schools in Victoria. And transcription is one of these core services, and that's where 3D prints fits in.
We'll start just by explaining a bit about what an ARC linkage project is and what ours is looking at specifically. ARC linkage projects are funded by the Australian Research Council to support research that's directed by the broader community to fill real world needs. And the research is led by an Australian university, but they must have community or business partners to help direct the research. The partners help to direct the research and they commit staff time, also resources and expertise, of course, and also cash if possible. And then all of the contributions of the partner organisations are summed up in terms of finances, financial value, and the ARC provides funding to match this total value from the partners and from the university. For our project, we're looking at 3D printing for touch readers, and it's led by Monash University. Our partners are the Statewide Vision Resource Centre, so that's the Department of Education and Training Victoria. Also the Roundtable on Information Access for People with Print Disabilities, which is actually an umbrella organisation with a lot of members. And for this project, the South Pacific Educators in Vision Impairment, Visibility in WA and Blind Low Vision New Zealand have been particularly helpful in assisting with the project. And our other partners are Guide Dogs Victoria, Next Sense, which is formerly known as RIDBC, and the Royal Society for the Blind in South Australia. So we've been able to pull from all of that, those resources and expertise. So they help to direct the project. When they have particular ideas, then we can work on projects specifically for our partners. And we also have oversight by an expert advisory committee that meets quarterly, and it has representatives from each of those partner organisations, but also from Blind Citizens Australia, the Queensland Tactile Mapping Committee and Vision Australia. And we've made sure that more than half of the people on our expert advisory committee are actually blind and low vision and touch readers themselves. So in terms of aims, the overarching aim of the project is to identify how 3D printers can best be used for people who are blind or have low vision and are touch readers. And this includes examining when 3D printing is better suited than other formats, how to design models specifically for touch reading, and how to teach the use of 3D prints and also labelling techniques. And we're looking at this in 2 main application areas. So the first is education, which we'll be speaking about mainly today, and the second is maps for orientation and mobility. The second overarching aim of the project is to build capacity for 3D printing within the accessibility sector. So this means raising awareness, building support networks, and developing guidelines similar to those that already exist for other formats. So for things like tactile graphics, we already know how to produce best quality, but for 3D printing, we've come in without any of that information.
Why 3D printing for touch readers? Graphics are a common part of education. So there are a variety of ways in which a graphic can be conveyed to a student who is blind or has low vision. Descriptions of graphics is always useful, but it's not enough on its own if the graphic illustrates a new concept or it has some spatial aspects that are important. So tactile graphics, also called raised line drawings, are the most common strategy for touch access to graphics in textbooks. And the most common methods used today are the three photos on the screen. So there's, on the left, there's tactile graphics used with swell paper, which are printed and then heated, and the black parts swell up so that they can be felt. There's embossed graphics in the center. And then on the right, there's a handmade collage. So 3D models were once best practice for education of blind students in special schools, where volunteers would construct large models by hand for use by a group of students. In Queensland, R.F. Tunley was known as the fairy godfather of blind children for his work making innovative models for blind students, including the model of Braille House, which is shown on the screen, which lifts on a hinge to reveal the internal rooms. However, the creation of handmade models became impractical with the advent of integration of students who are blind into mainstream schools. And there's also been a move towards digitisation. So this is where 3D printing comes in. And 3D printing is a new maker technology. And you can see a video of it on the screen. And it's suited for prototyping and small scale production. The cost of a printer starts at around $400, but you're looking at around $1,500 for a reasonable quality printer. And the filament costs around $40 per kilogram. As shown in the video, the most common 3D printers use an additive process, whereby the plastic filament is melted and printed in one thin layer at a time and then builds upwards. The 3D printing community is very much about sharing, and there are hundreds and thousands of models on every possible topic that you can download for free and then print for yourself. So in education, there are two main areas where 3D printing is particularly useful for students who are blind or have low vision. The first, as we mentioned, is accessing graphics, particularly when these graphics are 3D in nature, and then when you can't touch the real object itself, and when interaction or manipulation could assist with understanding and engagement. And then the second is in creating specific tools for the classroom. So here are some examples of what we're talking about. So graphics are used across the curriculum and across subject areas. Some of these can be turned into tactile graphics, but others are better suited to 3D printed objects. So the first object on the left is a pie chart. It's interactive, so each of those three sections, you can move and make them bigger or smaller. They rotate around the center. Each section also has a different texture on it so that it feels different, and a different color for a low vision student to still be able to use this pie chart. In the top right corner, there is a chemical bonding set in which each piece represents a different element. The pieces can attach and detach to demonstrate covalent bonding in chemistry. As an example, the joined pieces on the right are a water molecule. So you've got the oxygen and then two hydrogens hanging off either side of that. And in the bottom right-hand corner, there's a print to aid students' understanding of topography and contour lines. This print matched with a tactile graphic of a map of an area. So the student could connect the 2D drawing with the 3D shape that it's representing. So at SVRC, we've got a catalogue of 3D prints that we've linked with subjects across the curriculum. Some of them have been designed in-house, some of them are from other sources, and we've got that catalogue is on our website. And a lot of our designs are also on Thingiverse, which is a repository of models that we'll talk a bit more about later.
3D printed tools for the classroom forms the second category of 3D prints that is requested for students who are blind or have low vision. And I feel like this one has implications for the wider disability community as well. So while schools and accessible for production facilities are largely buying 3D printers specifically to address curriculum needs, we eventually find that they're also using the 3D printer to create specialized tools as well. So they don't set out to do it, but it's something that is so good that they can't help themselves, and it's very helpful. So as blindness and low vision is relatively rare, individuals might have intersecting or individualized needs. The commercialization of products is often not viable. So there might not be a product for someone who is a one-handed braille reader, or it might be so expensive, too expensive because there's too few people. So maker technologies such as 3D printing offers a way of developing and producing really specialized products that can then be shared with others online to reach those other two people who are a left-handed braille reader. And so we'll describe some examples that might serve as inspiration for similar products that you could develop and use in other fields. So this first one is a braille finger writer guide. So I've got a Perkins braille writer in the background behind me, and it's the way that you type braille. So it's got 6 dots and there's 6 keys, and you need to, as you're writing braille, keep your fingers on those keys. But there's a tendency when you're learning to slide around and then lose track of where you are. So a vision specialist teacher built a little finger guide using cardboard to just stop their student from sliding the fingers around. And then that was then developed into a 3D printed model that was a lot more robust, could be reused, and it can be shared. And this has now become super popular, and it's being printed in the hundreds all over the world. The next example, and it's available on YouImagine, so the link is there. Next example is Braille tools. So the Braille swing cell is a really simple device that we use to demonstrate how the keys on the Braille keyboard, which were set out in a line, are related to the dots in a Braille cell, which form a rectangle. So it swivels around, and it's got removable pegs to demonstrate the configuration of different Braille letters and symbols. And this model is 3D printed, but it does also use just a standard screw and nut. So you can, of course, combine 3D printing with other materials if you need things like strength or other requirements. And the other example that we have on the slide is the slate and stylus, which is a tool for handwriting braille. So you'd need a guide for where each dot goes, and they are available commercially, but 3D printing is cheaper and it might be more convenient. We've actually got a braille bombing event coming up, and we'll have lots of people doing brailing together on the streets, and I'll be printing off some extra slate and styluses to use for that event. The next example is games. So braille and tactile dice are used for classroom learning in numeracy, but they're also used for leisure games, and it's always supporting numeracy and tactile ability. So they might have tactile dots, or they might have the number written in braille. And Dots RPG are a company that have produced a range of different tactile dice, and their models are available for free download to print your own, or you can order them to be printed and posted to you through Shapeways, which we'll talk a bit about later as well. And we've also been working on modifications of popular games so that they're accessible through touch. And an example on the screen is 3D printed Scrabble tiles, which have got indented print for people who have low vision and raised braille letters. And these can be used for Scrabble, but also for lots of other games. And so, as I said, the games are help with tactile literacy, and they make touch reading fun and also send an important message about inclusion.
Tactile rulers, protractors, compasses, or measuring tools are another item that can be in high demand because previous suppliers are no longer selling them, so 3D printing becomes a good option. 3D Organ Bit is a German site, which is linked on the screen. It's dedicated to sharing free 3D models for blind students, and they have lots of different tactile rulers and similar tools available, including a signature guide, tactile graphing coordinates, a compass, and other things like that. At SPRC, we've designed a few different versions of protractors because sometimes they work better for some students and not others. And so we're up to about version 3, I think, and working with feedback from teachers in schools as to what works best for students. So we'll go on to talking about the outcomes of the project.
So first up, I've got on screen a list of formal research papers that have resulted from the project. I won't go through them individually, don't worry, but they do include both controlled laboratory studies for comparisons between 3D printing and other formats, and also observations made in the wild for real life use of 3D prints, which can sometimes be different from what happens in the lab. So this work has provided us with a strong evidence-based foundation for the next outcome, which is guidelines. So we're producing guidelines and distributing them through the Roundtable on Information Access for People with Print Disabilities. I'll call them Roundtable for short. And the guidelines are being released in sections on the Roundtable website, but they'll be collated into a more formal document when the project is completed. We've already produced guidelines on when to use 3D printing for touch readers, where to find existing 3D printing designs, design software for creating your own 3D prints, 3D printing by people who are blind or have low vision, so how they can do it for themselves, other methods for creating 3D models apart from 3D printing, labeling 3D models, so this could include braille or audio, how to prepare 3D prints for touch readers to make sure that they're smooth, no sharp edges, all of those sorts of things, and also how to teach or read 3D prints for touch readers. And we're still working on one final section, which is design guidelines for 3D models for touch readers, with advice on things like thickness and textures, symbols, distances between things, those sorts of things. And these guidelines are already being used a lot by the community. So when we first started the project in 2018, 3D printing was only available for touch readers through the South Australia School for Vision Impaired in South Australia, of course. But throughout the project, we've been trying to support adoption. Firstly, through awareness raising. So we've given lots of presentations and workshops and webinars like this one, so that readers and teachers and accessible format producers understand why they might want to use 3D printing and also what sort of materials it's suitable for. And we've also created support networks. So there's a Facebook group called Blind and Low Vision Printing that's got around 200 members now. And we also have a group under the auspices of the Australia and New Zealand Accessible Graphics Group that meets monthly to share ideas and designs. And we also hear from guest speakers, and often those guest speakers join us and come to the keep coming to meetings afterwards. Most of the members are working in education for blind students, and we range from experts to beginners so that we're able to provide each other with a lot of help. And it's a great meeting for me to run because I don't have to do much talking. Everyone has got lots of ideas to share. We also have a Teams group where we can chat throughout the month and share our resources. So now in 2022, we've got to the point where we have got a number of organisations that are producing 3D prints for touch readers. So there's 6 organisations across Australia and New Zealand as on the slide. And just comparing elsewhere, there was a recent study in Washington and New York with vision specialist teachers who were really keen to use 3D models for their students, but not one of them had access to 3D printing. So I think we're doing pretty well here now.
Adoption here at SVRC of 3D printing started back in around 2019 when we received funding to purchase 3 3D printers. Initially, 2 of them were loaned to schools as part of our technology lending library, and another one was kept here at SVRC. However, the ones loaned to schools were returned to SVRC and are now used here instead. In order to get new technology going, you need someone to champion it. And schools are busy places, and unless someone has taken 3D printing on as a project of sorts, it's likely that it's just not going to happen. So I've been one of the drivers here at SVRC due to having a background in maths and science teaching, an interest in how to engage students in STEM fields, and supportive bosses who've encouraged me to develop my skills in 3D printing when I'm not doing my usual job of managing the equipment library. As Leona said, the ANZAG group that meets monthly has been a really important part of our adoption of 3D printing, because it provides a place to share ideas and learn from one another. And so finding collaborators is really important to getting started. Another side to that collaboration has been with school staff on the ground. They can provide feedback as to what's needed for students, and testing things out in schools, that what actually works in a classroom versus what you might think works when I'm sitting here in my office. You need people who are willing to go through that process of getting a prototype and testing it out and giving you feedback and trying out another one and having a discussion. And not everyone has the time or wants to do that, but we've had a few great people who have jumped on board and are very excited as well to see what's going to happen, how things can be used for students to make education better for them. And the last thing that's been important in our adoption has been communicating what's actually available, because until people know, because it's so new, they just don't know what to ask for, or that it's available for them to use. So as I said before, we created a catalogue of prints so that a school staff or the visiting teachers who go out to schools and work with students who are blind or have low vision can look through what's available related to a subject area or a topic, and then they can ask for it because they know that it exists. We also often include new designs in our fortnightly newsletter just to get the word out. So there's a example of some photos that you might put in, and a description of how it all works. Having said all that, the best uptake has been from the visiting teachers who actually come into the centre regularly, because they can see examples, and once they see them, they go off and use them. So part of our sort of next process is to get things out more widely to those who can't come into the centre because they live a great distance away. So we've started making kits of things like space or cells, so that they're very clear what they're used for, and they can go out and come back in relatively easily, even without coming into the centre itself. In terms of what's happened in the classroom and the feedback we've got so far, we had a lot of remote learning here in Melbourne in the last couple of years, so it's been a bit of a slower process than we thought it might be. But here's a couple of prints that have gone out. So in the top right-hand corner, there's a photo of a solar system print. It shows each planet and the sun in correct proportional size, and the back curve section represents a part of the sun. And then the planets are in a line across the front. There's some braille labels on the base to aid in orientation of the print. And the main response so far from blind and low vision users has been either the sun's that big, or wow, Earth is so small. And this sort of shows that proportional and spatial concepts are very difficult to convey in the 2D. And this is a good use of the 3D medium. And in this case, you can't touch the real thing, so you need to provide them with a model. Down the bottom of this slide, we've got photos of a print and then a tactile diagram that goes with it. The transcription team at SVRC identified a student was studying medieval castles, and there was some worksheets showing 3 different kinds of medieval castles. And so they asked for 3D prints that match these worksheets. Then the tactile diagrams with the braille labels were produced to match the prints, and the student could explore the prints of the 3 different castles while classmates watched a video showing the castles from different angles. The sighted classmates were also interested in the models and chatted with the student about them. And many prints will assist all students in a classroom to understand a concept, and it's often an interesting thing for them to look at anyway. And in this case, it helped the student engage with the curriculum, but it also provided a shared learning experience for all the students in that classroom. So here are some suggestions for how you might get started with 3D printing. So in terms of designs, you can find designs from others, and there are many repositories with lots of free models on them. Be Tactile is one that's specifically for blind and low vision users. Thingiverse is a general site, and that's where me and Leona have put up models that we've designed. And it has a huge array of models, so it's a good place to start just to see what's out there. Terrain STL allows you to choose a rectangular area of the Earth, and it will then produce a topographical map of that terrain in that area. And STL Finder is a meta library that searches all the other repositories to see what's out there again. Now, if you're feeling a bit more adventurous and you want to get into designing your own models, there are lots of programs to do that with. And some of these include Tinkercad, OpenSCAD, and Fusion 360. As Leona mentioned, there's a I've forgotten the word now. They're all reviewed on the ANZAG website. So there's a description of what each of them do, the pros and cons, so you can find one that might suit you best.
And in terms of printing, if you're not expecting to do 3D printing on a regular basis, but there are a couple of items that you want, there are lots of 3D printing services that are available. So we've got the 3D printers are getting more common in schools, and they're also, you can find them in public libraries. But otherwise, as an example, Craft Cloud is a 3D printing marketplace service where you can upload a model and then specify what size you want or what sort of materials you want. And then you can get quotes from a range of nearby printing services to compare and get the best deal. Shapeways is a high quality 3D printing service that designers can link to directly. So I showed the Dots RPG dice earlier. If you want one of those, you can order it just directly through Shapeways. And in Australia, Next Sense are able to produce 3D prints for people who are blind or have low vision using NDIS funding. So there's lots of options out there. But of course, 3D printing services are going to be more expensive than doing it yourself. So if you do want to take this on a more regular basis, then there are a really wide range of 3D printers available. But we do find that FDM printers, which is the one that we showed working earlier, it's the most common type and it uses melted plastic. It's suitable for most jobs, and it's also cheaper to buy and to run as well in terms of materials. So it's an excellent option. Even if we have better printers, we usually use the FDM printers most of the time. And we recommend Prusa or Ultimaker brands because they are reliable. There's a big community of people to help if things go wrong, and you can fix them easily yourself. They're designed that way. And also they're more accessible for people who are blind or have low vision to use themselves. And as Sarah mentioned, you will need a champion to help run the printer who's willing to tackle the technical challenges, not just of printing, but also troubleshooting and repairing when things go wrong. Obviously, if we are melting plastic in a hot nozzle and then it cooling down and then melting again, you're going to get blockages is the most common problem that happens. But as I said, there are a lot of good resources online and you just need to be willing to give it a go. It's not that hard to learn. If you are interested in getting started with 3D printing, please don't hesitate to contact us. We've got our details on the slide along with our 3D printing design collections on Thingiverse. And also we've got the details of the ANZAG 3D group. Contact us if you'd like to join us. And also the Blind and Low Vision 3D printing group on Facebook, which you can join if you're interested. The Monash Inclusive Technology Group is also really keen to hear from you if you'd like to partner with us on future projects on any research topic, not just 3D printing. So anything relating to technologies for people with disabilities, where you want to have a research background and get things up and running. We're currently working on putting together an ARC linkage application relating to sonification, which is turning data into audio for access for people who are blind or have low vision. But we're also interested in exploring other topics that have got that community driven need. So we would love to hear from you if you've got ideas about things that you'd like to work on with us. So thank you everyone for your attention today, and we're hoping that you've got lots of questions for us.
Thank you so much, Sarah and Leona, for your presentation today. It's fantastic to see the work that you are both doing and the results that you are getting. Our collaborative has been inundated with questions today, so I just wanted to go through some of those questions with you both. So you mentioned 1,000 models are available. Are these open sourced, and how do you access them?
Yes, so on a site like Thingiverse, there are hundreds of thousands even of models available, and they are all there for free. There are plenty of 3D models that you can pay, like you need to pay for on other sites, but Thingiverse itself is all put up there free, and yeah, so there's a lot to go and have a look at if you want to.
Fantastic, and maybe we'll be able to put that link up on the Community Care Smart Assistive Technology Collaborative for people to access. Derek has asked, is the cost of the machine a barrier to adoption, and do you think the cost of machines will reduce over time?
I think, well, obviously cost is going to be a barrier initially, but you can start off with just like a $200 to $400 machine from Aldi, so you can get into it at a fairly low market point. And yeah, I think that the cost has been coming down, but it's also been going up. So there are some cheaper machines, and there are also machines that you can construct, like Prusa has options to construct the machine yourself, so that makes it a lot cheaper as well. And then in terms of some machines getting more expensive, that's because they're getting a lot better and a lot more reliable, and there's a lot more features that they can build into them. So there's a really broad range of options that are available.
That's great to know that there is a variety of options and levels for people to gain access to. So Glennis has asked, are the 3D printing machines user-friendly? One of the barriers we have in implementing these technologies is the digital literacy of our staff.
Yeah, so Sarah, did you want to take that one?
Yeah, sure.
Yeah.
So when we got our printers, we were coming to it, essentially hadn't used them before. We had training by the suppliers, so they were local suppliers in Melbourne, and they came out and did initial training with a group of us, and then sort of have provided a bit of troubleshooting support. But then the printer maker has very good videos on how to, repair all the parts and do all the different bits and pieces. So if you've got the time and you want to, I think you can mostly get yourself up to speed, but it does take a bit of time. And also, yeah, the benefit of having other people who are having a go with you is very large, because you can ask those questions like, why does my print keep on doing X, Y, Z? And usually someone else has experienced the same thing and can give you a suggestion.
We have that a lot at our ANZAC 3D meetings. Someone says that something's gone wrong, and everyone else says, the same thing happened. This is the best way that I found to fix it. So, yeah.
Great. And the last question is from Jacob. Great presentation. Thank you for being a new approach. What do you think are other applications you haven't tried yet?
Ooh. I mean, we didn't talk today. We're focused on the education side of things, and we have also been looking at 3D printing for mapping. So that's an area that we have explored. I just didn't talk about much, but it's been fantastic in terms of creating the 3D printed maps and icons and symbols. And also we're finding that it's not just for people who are blind or have low vision. So the materials that we're producing are really appealing to everybody and maybe reduce the cognitive demand in order to understand them compared with other formats. So in terms of other things you could create, there's a lot. Sarah, do you have ideas?
Well, we sort of started off in the STEM fields, partially because that's my background, so that's sort of where I know about. But we have, you know, geography, then we worked out that was a big area because you've got, you know, contour maps and how does that work 2D to 3D, and even into history to be able to, you know, do a model of the Pompeii volcano or you know, a pyramid, how they were designed, where most kids would get to see a video or a diagram. That maybe this is another alternative for blind and low vision students. So yeah, we've kind of started off within the STEM and then moved out into other subject areas. So I don't know if maybe we'll move out into more depending on, yeah, we'll see where we go.
That's great. Very exciting work. So what's next for the collaborative? Before we close this session, I wanted to bring your attention to an upcoming event the Community Care Smart Assistive Technology Collaborative is sponsoring. On the 4th of April, the Enabling Better Aged and Community Care for Forgotten Australians National Forum is being hosted by the National Aged and Community Care for Forgotten Australians Roundtable. The National Forum will showcase what the future could hold for aged and community care for forgotten Australians, and will spotlight the need for co-designing new models of care, what the evidence is telling us, the need for change approach and service models, international experience, and the need for skilled and capable workforces across all types of care. Registration for this event is now available, and for more information on the event and how to purchase tickets, please visit the community resourcing website on your screen. We will be posting today's webinar on the Community Care Smart Assistive Technology Collaborative. So if you haven't already done so, please go online and register. You will also gain access to hundreds of resources, exclusive events and forums. If you have any further questions or inquiries, please email us at sat@communityresourcing.com.au. Once again, I would like to thank the members of the collaborative research team and today's speakers, Sarah and Leona. Thank you for everyone for attending today's session.